Newton's second law. If there is a net force on an object, the object accelerates. Its acceleration is directly proportional to the net force. Its acceleration is inversely proportional to the object's mass. Its acceleration is in the same direction as the net force.
Here we see Kelly demonstrating Newton's second law of motion. She applies the same net force to both objects. However, because the weight has more inertia, it does not go as far as the ball. Therefore, the ball has less inertia and is able to accelerate and travel further than the weight itself.
Here we see how the equation F equals ma can be directly and inversely proportional. The net force is directly proportional to acceleration, meaning the more the force, the more the acceleration, and vice versa. Mass is inversely proportional to the net force, meaning the more the mass, the less the acceleration, which means more force is needed to move the object, which we demonstrated in this video. Here I am demonstrating how to find the net force of the weight. It has a mass of 1.019 kilograms and an acceleration of 5 meters per second squared. To find the net force, you would simply multiply the mass, 1.019 kilograms, by the acceleration, 5 meters per second squared, to get a net force of 5.1 newtons. Finding the net force of the ball is similar to the weight, just using different numbers. The mass of the ball is 0.095 kilograms. The acceleration is 10 meters per second squared. Like the weight, I would multiply the mass, 0.095 kilograms, by the acceleration, 10 meters per second squared, to get a net force of 0.95 newtons.